Sharing my screen. Confirm that it's visible to you. Okay. So this is our fourth session. For those one who are joining for the first time, my name is Martin Indecha. I work for Nokia as MPBN Paco SME engineer, and I've been the trainer for the IPRAN technology. So we've had multiple sessions. We covered our first session, our second session, and the third session. And this is our fourth session of the IPRAN technology. And in this session, we'll be focusing on how to do BGP design for IPRAN network. So in our previous session, we have discussed about the general architecture of IPRAN network. We've also discussed uh, the IP address and IGP design for IPRAN network. And in our last session, we also covered how to do the configuration and troubleshooting of IGP protocol for IPRAN network. So the previous session, this session, of course, it's building from our previous sessions, because before you deploy BGP on a network, definitely you need to be able to ensure that you have connectivity. You need to configure the IP addresses on the interfaces. You need to go ahead and configure IGP like ISIS or OSPF on the network. And now once you have established connectivity between these different nodes, you will now be able to configure BGP and go ahead and deploy things like MPLS and other details, like when you are configuring the services. So we are just still preparing for the service deployment, which will be coming in the next few episodes. So in this episode, we are just focusing on how to do BGP design for IPRAN network. So, the topics to be discussed today are based on the survey that I did last week. I know we have guys who haven't worked with BGP. We have those one who are experts in BGP. We have beginners in BGP. We also have intermediate, those one who have worked with it but not for long, and they are all trying to understand BGP protocol. So we'll have an introduction to BGP just to make us familiar with this protocol, and to allow us to be on the same page when we start discussing about BGP design principles for IPRAN network. So that will be the first part, just to introduce BGP as a protocol. The next part will be to discuss BGP design principles for IPRAN network, and then we will have a question and answer session. But anytime you have a question, as usual, you are allowed to unmute your mic and just ask as we progress with the session. But at the end of this presentation, we also have another separate few minutes for question and answers. So let's start our session. And we are starting our session with some discussions, the open discussions. As usual, we try to make it interactive by you unmute yourself and try to answer the question, try to share your input on different topics that we'll be discussing. So some of these topics that we need to try and understand is, what do you know about BGP? So BGP is a very common protocol. What do you know about BGP? Anyone who can share their input? You are allowed to unmute and tell us what you know about BGP protocol. Hello.
Yeah. Um, from Kenya, working as a data center engineer. So I've worked with BGP. From what I know, is an exterior gateway protocol that uses autonomous system to define the best path that we can use to run the traffic. I've seen several vendors do use BGP within the data center to peer, among others. On my end, I'll say BGP runs the world. Thank you.
Anyone else? Tell us what you know about BGP. Yes, proceed. Guys, let's unmute and make it an interactive session. What do you know about BGP? Do you have BGP running in your network? I hope I'm audible. Or should I start calling names?
Hello?
Yes, yes.
Um, Guys, I can't hear a thing. Is someone speaking?
Are you able to hear me?
Same thing here, actually. I don't hear anything, so maybe the presenter should do something.
Hello. Hello.
I think the issue is the Martin, yeah?
Hello.
Hi, Martin, we can hear you now.
Yes, it seems a problem with my mic. Let me just try again.
Okay.
How about now?
I can get you.
It's audible.
Okay. Sorry. I was wondering why no one was responding to me. Sorry for that. Let me go back to the presentation mode. So we were discussing about what you know about BGP. Last chance or two, one or two chances. Anyone who can tell us what they understand about BGP? Guys, you can hear me?
Yes, we can hear you.
Yes, Martin, we can hear you.
Okay, thank you. Yes, just open your mic and proceed, Arthur.
Hello, morning all. I want to talk about BGP. BGP is used for one connectivity. It's the thing I want to add.
Okay, thank you. Last one, last person to tell us what they know about BGP.
Hello.
Yes, proceed.
Okay, it's Kasim here from Tanzania. So, in short, BGP is a protocol for internet. BGP is used to connect different carriers over the internet. The BGP use the concept of AS numbers, in which every carrier will have AS number. So if there are rules which need to be shared between those carriers or the data centers, different part of the world, the network, we use the AS numbers to share those rules. So simply BGP, the protocol of internet. Thank you.
So yeah, BGP, that is, we call it the Border Gateway Protocol. As they have said, this is a protocol of the internet. The next topic will be, why have you deployed BGP on your networks? I know we are all, majority of us are network engineers working on service provider networks. So why have you deployed BGP on your networks? Do you have an understanding why you have BGP running on your networks, and why not other protocols, especially for the internet connectivity? Anyone who can respond to it can proceed. Why do you have BGP deployed on your networks?
Yeah. Hello, good afternoon all.
Yes, Fabian.
Yes. Irrespective of the fact that you can use other protocols like OSPF, ISIS, and you have other protocols like RIP. But the whole thing about BGP is the BGP's extensibility. And for internet connection, okay, you can do BGP peer with a node that you're not directly connected to. Okay, unlike other protocols. So that is why mostly we use it for internet connection. Thank you.
Thank you. Last person, why do you have BGP running on your network?
Okay, Skasim again. The a simple reason for having BGP in the network is, I can say, BGP allow better scalability than other routing protocol. Let's say we take an example of SPF. You have SPF running in your internal network, and then one of the router failed. So the whole process, the whole SPF neighborship calculation, the adjacents, all it have to redo it again so that it converge, and the routes are being able to be shared again. But it's different with the scalability issue with the BGP, where even if one router fail, it will automatically, or it will just take the next available path without doing the convergence and that.
Okay, thank you. So when we talk of BGP, we are talking of the scalability and flexibility. So when you have a service provider network that you are deploying maybe a thousands of routers and it's covering different regions, it's always recommended that you go with BGP. It will give you the flexibility of even controlling how traffic flows in your network. It will also give you the scalability. You are able to scale your network when you are using BGP as compared to other protocols like OSPF and ISIS. So those are the reasons why we have BGP running on our network. Another question that we need to discuss here, what are some common features of BGP? So I know we've configured BGP, we have BGP running on our network, and BGP as a protocol has some common features. So what are some of these common features that you know about BGP? Which port does it use? Is it TCP? Is it UDP? Such common features. Anyone who can respond can proceed.
Okay, BGP uses TCP port 179 to establish connection for handshake.
Thank you. So it uses TCP port 179. Any other feature that we know of?
Yeah, hello.
Hello.
Yeah, so BGP supports multiple protocols such as IPv4, IPv6, multicasts, and then VPN version 4 routes.
Yes, it has support for multiple protocols. Any other feature? Thank you, Jonas.
Okay, I'll say on my end, starting with the basics.
Yes.
It is it's a part vector protocol that uses a list of autonomous system number to determine the best path to reach its destination.
Thank you. So it's a path vector protocol with which depends on different different attributes or path attributes to determine the best paths to forward the traffic. Any other feature that we know of? This is a knowledge sharing session, so you are allowed to share your knowledge about BGP. A last one. Okay, to save time, we'll move to the next question. How do we classify BGP path attributes? What are the common classifications of BGP path attributes? Anyone who can respond to this? Some common Classification of BGP path
Yeah.
attributes. Yes, proceed.
Yeah, we have a well-known mandatory.
So we have well-known mandatory, yes.
Yeah, which will include the attributes which must be recognized for it to update, such as the SPAF and the origin.
Okay. Another classification apart from the well-known mandatory attributes.
Optional attributes.
The optional attributes. Anyone else?
Well-known discretionary.
So we have the well-known discretionary attributes. So for the optional, of course, we have the well-known mandatory, well-known discretionary. We have the optional transitive, optional non-transitive. So those are just some basic classifications for the path attributes. To the next question is, what are some common BGP path attributes? The common BGP path attributes. So those were classifications. Now we are talking about the common BGP path attributes. You've mentioned the origin. Which are the others?
Local preference.
AS. Okay.
Proceed.
MED. MED.
MED. Okay.
That's mentioned local preference.
There is local preference.
Pre, yeah,
Please.
preferred value. Yeah, like you know what we they
There's
say
some noise
in
from the
Cisco they say
background.
wait,
If you're not speaking, please mute.
wait, wait, or preferred value.
There is wait, there is preferred value. If you are not speaking, please mute your mic. If you have noise in the background, please mute. Okay, any other attribute that we know of?
There is a community.
We have the community attribute. Last one. Okay, we will cover them. What are some common BGP messages? So for protocol to work, definitely, for example, OSPF or SIS, the two routers has to exchange some messages. So BGP as a protocol also has to exchange some messages to ensure that it can exchange the information, the routing information, the updates, the notification, even the errors. So we are looking at some common BGP messages that are used in BGP protocol.
Yes, we have the open message.
So we have the open message.
We have the keep alive message.
Keep alive message.
The notification message.
Notification.
And update.
And the update message. Okay. Then second last question is what are the stages of BGP state machine? So same as OSPF, BGP also has to go through some steps before it can now start to be fully operational, or before they can now start exchanging the routing information. So we have the BGP state machine, and we are looking at the different stages of BGP state machine.
The idle stage.
Idle state.
Connect state.
Connect.
Active.
Active.
Open send.
Open send.
Open confirm.
Open confirm.
And established.
And established. Okay, thank you, Dodge. The last question is, how does BGP select best route? So any protocol that is operating on a network, it has to have a mechanism that will be used to select the best path. OSPF will use metric. SIS will also select the best path based on a metric, which is cost. Protocol like RIP will select based on the hop count. So BGP also has to depend on something for it to be able to select the best route. So how does BGP select best route? Anyone who can respond to that, and then we'll be moving to our introduction to BGP.
There is a long mechanism to select the best path in BGP. First, it checks the local preference. Then it checks the locally originated. If the path is locally originated, it will be preferred. It will check the AS path list. The shortest AS path list will be selected, and there are further. It will check the MED value, then the origin type, and there are also multiple options.
Anyone else? Anyone else with a different or an addition?
BGP also prefers an external BGP route over normal BGP route.
Okay.
It also prefers a router with the lowest ID instead, in case most of this path are, in case they are the same or tied up. It also uses a router ID to choose the best path in out of the network.
Thank you. So it will BGP select the best path based on the path attributes, and there is a sequential process that is followed before the best path is selected. It will compare different attributes or different values for the different attributes before it selects the best path. Okay, thank you for your input. We'll now move to the introduction to BGP. If you have any question, feel free to interrupt, feel free to ask your question. So I know we've been talking about BGP. If you haven't ever heard about BGP, we call it the Border Gateway Protocol. It is an EGP, the external or the exterior gateway protocol. So compared to the IGPs we have like SIS or OSPF, RIP, EHRP. So BGP, it's an EGP, exterior gateway protocol, and it's configured between autonomous systems. So you can see that internet, we have isolated networks. So we can be having a network owned by one organization, or this one could be a network owned by a same organization but in different regions. So these are what we are calling the autonomous systems. So this is how the internet looks like. It has many different networks or the smaller networks which are divided into small autonomous systems, the ASS. And for us to achieve connectivity between these autonomous systems, this is where we are using EGP or the BGP as a protocol. So we'll configure BGP protocol to assist us to have connectivity between these autonomous systems. To the next slide, where we are now focusing on some BGP features. So BGP as a protocol has different features. The first one is that it's a dynamic routing protocol used between autonomous systems. So it's a dynamic routing protocol means it's not whenever there is an issue in the network, you don't have to manually intervene. It can dynamically switch the traffic to the available path. So it's an EGP that will control route advertisement, and it selects optimal routes between ASS. So BGP will never discover or calculate routes. It will just select from the available routes. And these routes that we are talking about, many times they are coming from IGP. And then we import them into BGP. So once we import these routes to BGP, now BGP will go ahead and select the best or the optimal route from the available routes. This one you have already mentioned. It uses TCP as the transport layer protocol, which enhances reliability. Remember, TCP is connection oriented. So this one enhances the reliability of BGP protocol. Then BGP peers, they are logically connected through TCP. So this is a logical connection between two routers. It's not physical. That's why when you are configuring BGP, you can configure BGP between a protocol that is between routers that are very far away from each other. So maybe these are the physical connections between these routers. When we talk of logical connection, we can have BGP session running between these two routers that are not connected at all. So it's just a logical connection between two routers, and it will come up without any issues. But for protocols like IGP, ISIS, definitely you need to configure them on the connected devices. You cannot have IGP running between these two routers unless you have some logical connection or unless you have a physical connection between the two routers. So this is a feature of BGP. It uses destination port 179, so it is TCP port 179, and the local port number is a random value. So the local port is always random value, but when you check the destination port is always 179. It supports CADR, transmits only the updated routes, so it doesn't, whenever there is a change in the network, that's when it transmits the route, only the updated routes. So it's a distance vector routing protocol, or we can say it's a path vector protocol. Remember, it has the path attributes that are used to determine the best paths for forwarding the traffic. So BGP as a protocol, it has loop prevention features. So it prevents loops using AS path and split horizon. All protocols must have some mechanisms to control loops. So BGP has this feature that are used to prevent loops in the network. It provides many routing policies to flexibly select and filter routes. Remember, when you are selecting the best path, it always has to go through some process. It will compare different path attributes before it selects the optimal route. Then it also provides a mechanism for preventing route flapping, improving stability. So we have BGP route dampening that helps to prevent route flapping in the network. So these are some common features about BGP as a protocol. Unless there is any question, we will move to the next slide. Any question from the team? Or any addition about BGP features? You are allowed to open your mic and respond. The next slide. So when we talk about BGP, we are talking about the autonomous systems. These autonomous systems are represented using what we call the autonomous numbers. And which numbers do we use, especially on the IPRAN network? So we know that similar to the IP address, we know we have private IP addresses, we also have public IP addresses. Many times AS numbers are also classified into private and public autonomous numbers. So autonomous system numbers have to be unique on the internet. So whenever you are connecting to the internet, you always have to ensure that you are using a unique AS number. If you use a duplicate AS number, your routes may not be able to go through the internet. So that's why it's always recommended that you have a unique autonomous number when you are connecting to the internet, because the AS path will be used to prevent the loop when you are routing your routes on the internet. So the public autonomous system numbers, they are assigned by IANA. So they are similar to the public IP addresses. So we have the public autonomous system numbers, and these one they are always assigned by IANA. So whenever you want or you require a public autonomous system number, you have to request it from IANA. It's the one that will be in charge. It's a body that will be in charge of assigning these public autonomous system numbers. So we have two types. We have the 2-byte and the 4-byte. Nowadays, I think the 2-byte is already exhausted. I remember for the 2 bytes, we only have 65,535 autonomous system numbers, which are not enough to handle all the requirements. Or we have so many small service providers that And even for the big service provider, they require many different public autonomous system numbers. So the 2 bytes, it's not enough, and that's why we have the 4-byte autonomous system numbers. So for the 2 bytes, we have different classifications. Just to mention, we have the reserved. So 0 is reserved. We'll never see an autonomous system number of 0. We have 1 to 64, 495. These are now the public autonomous system numbers. And then we have 64, 496 to 64, 511. These are reserved to use in documentation. And then we have 64, 512 to 65, 534, which are private autonomous system numbers. So when we are talking about the IPRAN network, many times we use this range. Many times we are using this private range. Remember, many times the IPRAN network doesn't connect to the internet directly. It has to go through the IP core, and then the IP core is the one that connects to the internet. So these are the ranges of the autonomous system number that we'll be using whenever we are deploying BGP on our IPRAN network. And then 65, 535, this one is also reserved. So when you are doing the design for the autonomous system numbers for your network, this is the range that you should be using for your IPRAN deployments. Many times we use the private AS numbers, and then we connect to the IP core. The IP core now, of course, it has the IGW that will connect to the internet or other service providers now using the public AS numbers. So for the 4-byte AS numbers, this is now 32-bit. So you can see that now we have these many autonomous system numbers, which are now enough. So the idea of the idea of the 2-byte and the 4-byte is similar to the idea of IPv4 and IPv6. So you can see that with the 4-byte, we now have these many autonomous system numbers. Of course, you can read further about the 4-byte autonomous system numbers, but we have this range that is reserved for private or internal usage. So you have a total of these many, and then you have this one reserved for private or internal usage for your internal use as a service provider. So this is just a quick discussion on which S numbers you can use on your network. Unless there is any question, we'll move to the next slide. Any question, any comment, any clarification you require about this? So BGP operating modes. So when we talk about BGP, we have what we call the internal BGP and external BGP. For internal BGP, we are configuring it between routers in the same autonomous system. So you have built your network, you've classified it into different autonomous systems. You will have to configure iBGP between routers in the same autonomous systems. And then we also have the eBGP that is configured between different autonomous systems. So these are the two types or the two operating modes of BGP. We have internal BGP and we have external BGP. Any question so far? To the next slide about BGP messages. Remember, this is just an overview of BGP protocol, just an introduction. If you want to dive deep into the protocol, then you will have to do further reading about these BGP features. So when we talk about BGP messages, we have 5 different messages. We have open message, we have update message, we have notification message, we have keep alive message, and then we have the route refresh messages. So these are just different messages that are exchanged between BGP peers or BGP devices to ensure that we have the exchange of the routing information between the two different routers. You can read later about the functionality of these BGP messages once I share the materials. For the BGP state machine, So we've mentioned that whenever you've configured BGP between two different devices, there are some states or stages that these two devices will go through until they can now exchange the routing information. So we have this BGP state machine. We call it the finite state machine. And it has 6 states. So we have the idle. Sorry. We have the idle, we have the connect, we have active, we have open send, we have open confirm, and finally we have established. So these are just some different steps that BGP will go through before they start exchanging the routing information. And they are all based on TCP port 179. That is the port that is used to exchange the BGP messages. To the next slide about the classification of BGP path attributes. So we have 4 main classifications. We have the well-known mandatory, we have well-known discretionary, we have optional transitive, and we have optional non-transitive. So for the well-known mandatory, these are attributes that all BGP devices can identify this type of attributes, and they are always present in any update message. So whenever BGP device sends a message to the other peer, it must have these well-known mandatory attributes. If they are not there, then errors will be reported. And then we have the well-known discretionary. Yes. So for the well-known discretionary, these attributes, they are also identified by all the BGP devices, but it's not mandatory that they should be available on the update messages. They may not be the update messages, but there are no errors that will be reported by the peer. So we call them the well-known discretionary. And then we have optional transitive. So optional transitive, the BGP device may not identify this type of attributes, but still accepts them and advertises them to the peers. So you don't know this message, you accept it, and you still pass it to the neighbor. So these we call them the optional transitive. You may not understand my message, but you just have to pass it to the next neighbor. That is it. You don't have to drop it. But for optional non-transitive, these devices may not identify this type of message, and if you don't identify it, you ignore them and you don't advertise them to the peers. So I send you a message, you don't get my message, you ignore it, you drop it, you don't advertise it to any other peer or any other neighbor that you are connected to. Those are what we call the optional non-transitive. So we have the well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. To the next slide now about the BGP attributes. These are the classifications. For the mandatory, we have AS path, next hop, and origin. For discretionary, we have local preference. We also have the atomic aggregate. For the transitive, we have aggregator, and we also have the community. So for the well-known communities, we have the no export, no advertise, the internet, local AS. And then for the optional non-transitive, we have MED, we have originator, we also have the cluster ID. So these are just some classifications of the BGP common attributes. A quick look at how BGP select the best path. So we have mentioned that when we were doing the discussion, there was a mention that BGP select the best path based on these attributes. So it has to compare, it has to go through a process before it selects the best path. So this is the process, and I will not go through it, but you can just have a look at it quickly. And it's a sequential process, so it has to compare check the first item. If the first item is okay, it goes to the next stage, it goes to the next stage until it can now have the best route. Until there is a tiebreaker between these attributes, then BGP will settle to that route as the best route that will be used to forward traffic. So you can see that the first one, it's always looking at the next hop. Is the next hop reachable? Is the next hop reachable from me? If it's not reachable, then I don't need to care about this route. I will just drop it immediately. So the next hop is always the first thing that is checked whenever BGP is selecting the best path. Then we have the preferred value. Preferred value, this is similar to weight in Cisco. And then we have other attributes like the IGP values, we have the AS path length, we have the origin types, we have the MED, and it will continue checking the peer type, checking the IGP cost. So for the peer type, we are talking about eBGP and iBGP. So whenever you have two routes, you have eBGP, you have iBGP. The eBGP route will always be selected as the best path. The iBGP will be ignored. You have the IGP cost, so BGP also will check. And this one comes in play, especially when you've selected the iBGP. So you have two iBGP costs that you've learned from a peer or two different peers. Now you need to go ahead and compare the cost for these two iBGP routes. We have other things like the cluster links, cluster list length. We have the router IDs. We also have the peer address. So once you go through this process, then BGP will determine the best path. Many times, of course, it doesn't go through to the end. It will just have to decide somewhere in the middle, or depending on the type of routes or the parameters configured for that BGP peer, it will have to determine the best route before it reaches the end of the sequential process. Do we have any question? Any question, any comment, any clarification on the introduction of BGP? That was the first part of our discussion today, just a quick introduction to BGP. So if there is any question, you are allowed to ask. If there is any comment or clarification, you can open your mic and share. Anyone with a question before we proceed to the next topic of our discussion?
Please, Mr. Martin, I want to ask, when you use BGP, you need to necessarily use MPLS or not?
Many times that we have BGP, because at the end of the day we have the BGP, I mean BGP MPLS IP VPN or BGP MPLS VPN deployed. So many times, of course, MPLS will be deployed on the network. We also have the BGP deployed. So it depends on the kind of setup, but many times majority, especially on the IPRAN network, we always have MPLS and BGP both deployed on the network. Or if you are using other protocols like SRv6, because you know SRv6 is replacing MPLS, or you have segment routing, it depends. But many times we'll have BGP deployed. We also have MPLS deployed on the network so that we can now deploy the layer 2 and layer 3 VPNs on the network. I hope that's clear.
Yes, thank you.
Any other questions?
Hello, Martin.
Yes, Edwin.
Can you repeat the statement of which protocol that will be replacing the MPLS?
We have the segment routing SRv6, I mean the segment routing version 6 that is now being deployed in place of MPLS. SRv6 or segment routing version 6.
Thank you.
Okay. Any other question before we proceed? Yes,
I'm in a
Ibe.
bit, I'm in a bit of a noisy area, but the variables, will you be giving example of variables of mandatory and well-known mandatory and well-known discretionary attributes of BGP? With the examples of what makes up those elements coming to play.
Anyone who can clear Ibe clearly? I can't hear you from my end.
I'm very sorry, I need to
You
find
can
a
you
short one.
can text you can text on the chat maybe.
Okay, I'll do that, I'll do that.
Yeah, just text on the chat, then we will respond. Anyone else with a question? As we wait for Ibe to send a question on the chat. Baron Kaka, you are too quiet today. What variables makes up a well-known mandatory attribute and a well-known discretionary? Okay, I will just go back to the slide. So for the classifications, this is what eBay is asking about. So we have the mandatory. For the well-known mandatory, we have AS path, next hop, origin. So origin, we have three types. We have the I, we have the E, and we have the question mark. We have the well-known discretionary, which are mainly local preference and atomic aggregate. So these are the different types of the different classifications. We have the transitive, aggregator, community. So Ibe, once I share the slides, you can get them on this page. I hope that's clear. Okay, we move to the next stage of our. So now we are shifting to the BGP design principles for IPRAN network. And the first thing that we need to try and understand is why are we deploying BGP on IPRAN network? So many times the IPRAN network, especially we know that this is majorly deployed on the service provider networks, and the service provider network is huge. We have a network spanning different regions. We have a network having many routers, and we have a network that is carrying different types of services. So on such a network, BGP is the best option, especially when you want to deploy different types of services, when you want to have control on your network of how traffic will flow from one region to the other. You also have to control how traffic will flow from your network to the other networks, like to the IP core or to the any other connected networks that are connecting to your IPRAN network. So BGP will give you the flexibility and the scalability that you need on your IPRAN network. With the different path attributes, you are able to control the traffic flow. You are able to handle many different routes on the IPRAN network, and that one can be done well with BGP as the protocol deployed on your network. We've already discussed about which AS numbers to use. You use the private AS numbers. And when you are deploying BGP on the IPRAN network, we have the concept of split horizon. Anyone who can explain split horizon? How does IBGP control loops in the network?
Yeah, just split horizon is just a mechanism that is used to control a loop where if a BGP router, if IBGP router sees an update from another IBGP router, it will drop it. in some areas.
Yes, so we have the idea of IBGP, I mean the split horizon, and with split horizon, whenever an IBGP neighbor receives a route from another IBGP neighbor, it doesn't advertise to other IBGP neighbors. So if you have, for example, if you have, we have a slide that will be covering this in detail, but just to highlight, if you have three routers, these routers are connected and we have IBGP configured. We also have IBGP. So with the split horizon, when you advertise this route to this neighbor, this is IBGP. This router will not advertise it to the neighbor, to any other IBGP neighbor. It will only advertise it to the EBGP. So if you have EBGP here, this route will be advertised to this direction, but it will not be advertised to the other IBGP neighbor. So this one brings a problem, and we need to fix this problem. Remember the architecture of IPRAN network. You have many routers connected in a ring, and you need to ensure that you have connectivity between these routers or between different networks. So how do you achieve connectivity? So we need to have mechanisms that will ensure that we have connectivity in our network. So the first is for the meshed BGP peering, which means you will have to configure BGP peering session between all these routers. You have a BGP peering session established directly to this router so that they can exchange the routes. This one, it's not scalable enough. You will have to configure so many BGP peering session, and also the network will be, there will be so many messages that needs to be exchanged. BGP messages that needs to be exchanged between different neighbors. So this one is never an approach unless you have a smaller network. Then you can go ahead and deploy the meshed BGP peerings. The best one that is normally used is the route reflector. So with the route reflector, you go ahead and deploy route reflectors in your network. So with this setup of three routers, you can configure the middle device as the route reflector. And then you don't need to have this BGP peering. And whenever you have another BGP router coming in, you only need to configure BGP session with the route reflector. So this is the most preferred solution, is the one that we deploy on IPRAN. And with this, you are able to control the route exchange from one place, from the route reflector, and you don't need to have the meshed BGP peering session between different routers. We have BGP confederation. This is like an AS within a bigger AS, so that you make them to be, I mean, eBGP. So that is BGP confederation, route reflector, and meshed BGP. Another question that comes in play is, should we use groups? So BGP groups, this is a very common feature in BGP. It allows us to, yes,
Hello,
yes, yes,
Martin.
yes,
Can you hear me?
yeah, can hear you.
Yes, Martin. Since we are talking design, I
Yes.
wanted to ask about route reflectors. What are some design principles govern the use of route reflectors? I mean, sometimes you can have two, three, and then also positioning them. You put them in the at the core side, such things. Are there some guiding principles?
Yeah, the BGP route reflectors, many times, of course, they are deployed in the core site. For example, when we talk of the IPRAN, then it will be deployed in the aggregation part of the network, and not in the access, because many times when I will use the next slide to illustrate about the route reflector uh, deployment on IPRAN network. Let me use the next slide. But of course, you can always have multiple. If you have only one, it's never enough. It may go off and you have connectivity issues. So it is always recommended that you have multiple route reflectors in the network, and they are always deployed in the aggregation or the core part of the network.
Okay.
So we were talking about groups. So if you've ever configured BGP on a router, you know how many commands you need to run for you to bring up a peering session between the two routers. And if you have 1,000 routers, you can tell how many commands you need to run for you to be able to bring up peering sessions among these 1,000 routers. So with the BGP groups, we can group these routers into logical groups, and then we can apply similar groups, similar commands on the groups. So this is similar to, how do we call it? When you are creating profiles for users, maybe you are creating login accounts for users in AAA. You just need to create groups and then you assign users to the groups. And then the users will inherit the commands from the groups. So this is a similar concept. You have BGP peers, you group these BGP peers into logical groups, and then the repetitive commands are applied on the groups instead of applying them on each individual peer or individual session that you are configuring on the router. For the dynamic groups, this is also something that you can deploy on the network. With dynamic groups, let me use the whiteboard. So with dynamic groups is very easy. Imagine you have 4 routers, maybe the aggregation, the CSGs, and then you have your ASGs. And you have connections between these devices. So with dynamic groups, these are your aggregation nodes. On these aggregation nodes, you configure dynamic groups, and dynamic groups are normally used when you have, for example, let me say, you know that all your routers will be in 10.10.10.0/24. And maybe you have 255 routers that will be deploying on your network. And definitely you won't deploy all the routers at the same time. You will be deploying maybe one router in a month, or 2 routers or 5 routers, depending on how fast your network is growing. So what you do is you configure this block on these routers as the block that will be used to establish dynamic peering sessions. So when you have a new router coming in, what you do is you just configure the access node. You don't need to do any configurations on the aggregation. Whenever the link is up, you don't need to do any BGP configuration, because this router will have an IP in the range of 10.10.10, maybe .200/24/32. So this router is able to establish a BGP peering session dynamically with the aggregation nodes without you doing any configurations on the aggregation nodes. So this is the idea behind the dynamic groups. And that is a very good feature that you can deploy in your network, just to ensure that you don't have to do any BGP configuration. That is, you don't need to keep changing the BGP configurations on these aggregation nodes. Once you have deployed them, that is it. You have just specified the prefix for the other nodes, and then they will be able to dynamically establish BGP peering sessions with the ASGs, or the aggregation nodes in the network. So this one controls or helps to minimize the number of changes that you are making on the aggregation nodes. You only configure the access nodes with BGP peering sessions. That is it. They will be able to discover each other and dynamically establish BGP sessions among themselves. So that is about
Yeah,
yes.
yeah. Question. That group configuration you made on the aggregation layer, right? Are
Yes.
you still going to configure the same group on that access node, or you only configure the group on the aggregation nodes?
aggregation node, you only specify that these are the prefixes that these routers can establish dynamic sessions with. So whenever you have a new router coming in and this router is configured in this subnet, then if this router receives BGP messages from any router with an IP in this range, then they will be able to negotiate the BGP parameters and establish BGP peering session. So for the dynamic configuration, you only do it on the aggregation node. On the access side, you only do the basic configuration that we normally do. You need to specify the S number, you need to configure the source address, you need to specify the remote peer. That is it.
Configure the group as a parameter on the access node, right?
Yes, but this one will just, I mean, these routers, they have the loopback IPs, right? Which will be used to establish the BGP session with the access nodes. So many times when we are doing group configuration, definitely we still do the group configuration on the CSG, but the value of BGP groups is on the aggregation nodes, because this is where we are configuring so many peering sessions, right? On this CSG, you are just configuring two sessions, one on this peer, on this SG, another one on this SG. That is it.
Okay, so you still configure the group parameter on the CSG, right?
Yes, many times we still configure the group parameter on the CSG also.
Okay, but if you don't like, you can still leave it, right?
Yes, yes. Remember, on the CSG, you only have two peering sessions. So even if you
Yes, yes.
configure manually, it's still okay. But on the
Okay.
ASG or the RSG, you have many, many peerings, 50 or 100 peering sessions that are established
Okay.
toward the CSGs. Because remember, on
Okay.
these SGs, you will have to establish sessions to all these CSGs in the network. And remember, these are just 5. You could be having 50, you could be having 100.
Okay.
So the value of BGP groups, it's primarily on the aggregation nodes, but you can still configure the groups on the CSGs.
Fantastic. Many thanks.
Okay, any other question? So apart from the dynamic groups, we also have the BGP in the AS option to use. So remember, in BGP we have three in the AS BGP options. We have option A, we have option B, we have option C. Remember, IPRAN network, as much as it's one network, we also have different autonomous systems deployed. So you can choose which in the AS, BGP, MPLS, VPN option to use. You can use option A, you can use option B, you can use option C. And even when we are connecting to the IP core or other external networks, you also need to decide whether you are using option A, option B, or option C. Sorry. So you need to decide which BGP in the AS option to use for the inter-AS communication between the different autonomous systems. I will come to that. Another thing that you need to also consider is you need to deploy BGP authentication on your network. It's always a good practice that you deploy BGP authentication, MD5 or the SSL authentication for the BGP peering session, just to ensure that, remember, BGP uses TCP and it will exchange some messages. So whenever you deploy BGP authentication, you are improving on the network security. No one will just come and plug in a device and configure BGP and then the session will come up. No, they have to know the BGP parameters configured for them to be able to do a third-party connection through BGP to your network. The other thing that you need to consider is also the BGP convergence speed. You need to also, when BGP session goes down, you need to be able to detect it faster, so you can configure things like BFD, you can adjust the BGP timers, and many other things that you can do to ensure that you speed the BGP convergence speed. So whenever there is a failure in the network, it will be able to converge quickly without and reduce on the downtime. Another thing that we need to also focus on is how to control traffic flow using BGP path attributes. Remember, when you have BGP deployed on the network, you could be having multiple exits. Even within the same autonomous system, you could be having multiple exits for the network. So you need to know which BGP path attributes you can use to control the traffic flow in your network. Any question before we continue?
Can you please explain how to speed BGP conversion speed again?
For you to speed the BGP convergence, the first thing is you need to be able to detect any failure, right? So I've mentioned that things like BFD that will help you to
Okay.
quickly detect any failure, maybe the link failure, so that it can switch the path that is used for BGP establishment or any other changes in the network. Things like BFD can help to speed that convergence speed. You also need to control the timers. You can configure BGP
Yes, yes.
timers. Yes, yes.
Oh, thank you.
So when we are talking about IPRAN, we know that, for example, a service provider in Kenya can have a network split into different autonomous systems, and these different autonomous systems are always assigned a different AS number. You you may consider having one autonomous system number, but the best practice is you always have to split your network into separate small autonomous system numbers. So you can have a town, you can have maybe a region or a state having a unique autonomous system number. And once you have this unique autonomous system number assigned, you also need to have connectivity between the different autonomous system numbers. So you will have connection from, for example, region 1 and region 2 has a connection, and then this is region 3 and region 2 also have a connection. If this one is our region 1 is our core site, you can see that we have multiple paths that we can reach our core site. We could go this way or we could go this way. So this is where you need to know which BGP path attributes you can use to control the traffic flow between the different autonomous system numbers. So you have your network, you've decided that I'm going to split my network into 6 or 7 regions, and then you need to go ahead and assign different autonomous system numbers to these different regions. Once you've done that, we'll go ahead and do what? Establish connection between the autonomous system numbers using external BGP.
Okay, sorry to ask this question.
Yes.
Now, these AS numbers in different regions, can they be referred to as an IPRAN region, where those IPRAN regions in different AS are connected to the IP core on equally on a different region? For instance, like you have a 6512 region 2, region 3, and also region 1. Region 1 is like the core, right?
Yes.
Now we can be running that region 2, region 3, and so on as an IP run, but the region 1 will be the IP core, right?
Uh, Region 1 could be the IP core, or it could be having the IP core present. Like it's still an IP run, but it has an extension, it has a connection to the IP core. Or sometimes, many times, what you will find on this design is all these regions are connected to IP core at some point. We have IP core somewhere here, we have IP core somewhere here. This is what I've seen in many networks. You have the IP core also distributed across the country, right? Or some regions have IP core connection, some doesn't have IP core connection. But even in region 1 that we are calling it the core site also has IP RAN presence. So it could be having both IPRAN and IPCO.
Okay, so I
But remember, those
understand.
are,
Okay,
yes, those are different networks, and the IPRAN will be in a different autonomous system number. The IPCO will be in a different autonomous system number.
okay, okay. I understand. This is just a basic concept where this all this region can be connected to IP cores, right? This
Yes, yes,
IP core you have represented here can still be an IP RAN site connected to an IP core
yes, yes,
on its own. Okay, thank you.
yes. Any other question?
Mr. Martin,
Yes, yes,
I have another question. Okay.
yes,
Uh, if we have a call from site in access ring, want to communicate with another site in access ring. Okay, so call flow will be passed through access ring, then aggregation, then core, and revert back to access site, or this two access sites can communicate directly without referring to core. I mean, if you have a call, voice call,
yes, yes, yes,
I'm asking about this point. For call flow,
yes.
will be flow from access to aggregation and core, and then it will be back again to access, or access sets can communicate directly without referring to core.
Because before we do that connection, we need some kind of signaling, right? So
Yeah.
for the signaling, definitely we'll have to go to the core and come back to the access, unless you have the signaling nodes also available in the access site. But for
Mm.
this, for the data, once we have the signaling in place, then the data flow, of course, we can have access and access communicating directly.
Communicating directly. But what is it, the methodology of this?
Which one?
You mentioned that for data they can communicate directly, right?
Yes.
How can we do that?
Okay. Assuming that we have, let's say we have a user connected here, right? We
Okay.
have a user at this place, and then we
Yeah.
have a different user connected to this place.
Yes.
If this
That's
is
what I mean.
Yes, if this is the case, you see, if we have the nodes responsible for the data and signaling in this access ring or in this region, then this traffic
Mm.
doesn't have to go through to the core, right? It can just
Yeah.
directly, because we have the nodes responsible for data and calls in this region.
Yeah.
Then
Yeah.
we
Yeah.
don't
Okay.
need to go to the core. But if we don't have those nodes responsible for the signaling and the data, then definitely we'll have to go to the core and come back to the access.
Ah. Okay. Okay. Yeah. Yeah. Okay. I got your
Anyone
point.
with an input on this, maybe I may not be right.
Mm.
But of course, before we have the connection between the two users, first we need to have the signaling part working. And if the signaling nodes like the MME,
Mm.
the SGSN, any other
Yeah.
signaling node that is needed for this connection, then if it's available in this region, we don't need to go to the core. But if it's not available, then definitely we'll have to go to the core and come back to the access.
Yeah. From
Yeah.
access to core and then back to access.
Yes, yes.
Yeah.
Especially for the
Okay.
signaling.
Yeah. Yeah. I mean this point in signaling. Yeah.
Yes, but once we
Yeah.
have the signaling established, you see, we don't need to send data from this user to the core and then back. No, we can just have direct connection
Mm.
between the two users, especially for the, you see, many times for the 2G, 3G, we always localize the services within the region, right? We'll have a
Yeah.
BSC here, we'll have
Yeah.
RNC,
RMC. Yeah.
yes,
Mm.
yes, so that
Mm.
this data can be localized.
Yeah. Yeah. Yeah.
Yes.
It's clear. Yes.
Okay.
Thank you, Martin. Thank
Okay.
you, bro.
So you have established connection between the different autonomous systems using eBGP. You will go ahead and configure iBGP within the autonomous system. How can I clear this? Let me try to just end this card and then. So we have eBGP sessions established between different autonomous system numbers, and then we'll still go ahead and configure iBGP sessions within the autonomous system numbers. So we configure BGP sessions within and also between the autonomous system numbers. So we have the intra-AS and we have the inter-AS that we need to consider when we are doing BGP design for the network. Now, when we look at the intra-AS, so for the intra-AS, we know that we have different nodes. This one we have discussed in our previous sessions. You have the ASGs, you have the RSGs, and then you have the access rings. Access rings, these are the CSGs, and the CSGs are connected to the radio equipments, the BTS, the eNode Bs, and the RSGs are connected to the controllers. So how do we go ahead to design BGP for such a setup? First, you see that this is a ring, this one that we are cycling. This ring has a connection to different SGs in the network. So we have a connection to SG1, we also have a connection to SG2. So when we are doing our BGP deployments, we normally configure these CSGs to peer to these two SGs. So we have a session established from this CSG to SG1 and another one established from this CSG to the SG. So we have redundant BGP connections established between the CSG and the SGs. So if we were to lose this SG, this SG will continue to function and the network will not experience any downtime. So we will have to deploy two redundant BGP peering sessions from the CSGs to the SGs. And similarly, we'll have to deploy two sessions for the SGs. You know that these SGs are connected in a ring setup with these RSGs. So we are establishing two BGP sessions also from the ASGs to the RSGs. So we have one to RSG2, we have another one to RSG1. If we were to lose these RSG is still able to function okay and our network will operate normally without any downtimes experienced. So this is how we normally design our BGP peering sessions. For these nodes, for these one that are hanging, you can see that this one, we just configure BGP session to the SG4. We don't need to configure BGP session to SG3. Why? Because you see, we don't have any redundant path for this CSG to reach to SG3. If we lose this connection, even if we have a connection, a BGP peering session between this CSG and this SG3, it will not have any use. It will not have any impact. This site will still be down. This one will still be down. So for the spar and chain, we normally configure just one BGP peering session to the connected ASG. Same to this, you can see that this CSG has one peering session only to SG1. We don't need to establish another BGP session to SG2 or SG3 because once we lose these physical connections, all these BGP sessions to SG2, SG3, SG1 will be down and our services or the site will be down, the services will be impacted. So when we are doing the design, depending on the kind of the setup, if it's a chain or a spar, we only peer to the directly connected SG. If it's in a ring setup, we establish two peering sessions. We have the primary BGP peer and we have the secondary BGP peer. So whenever we have the ring setup, as shown here, we establish two sessions, one to SG3, another one to SG4. Same to the SGs, we are also establishing two sessions, one to RSG1, another one to RSG2, so that we have redundant peering for the protection of the services. Do we have any question or any clarification that we need on this slide?
Yeah, that's clear, Martin. Also, we can deploy TE tunnels to optimize traffic and configuring hot standby to reach RSG1 and RSG2
Yes,
or
yes.
ASG1 or ASG2.
Yes, yes.
Yeah.
Whenever we have the traffic engineering deployed, definitely we can deploy the TE tunnels from the CSGs to the SGs or the ASGs to the RSGs and have the traffic engineering in place. That is correct.
Yeah, okay.
Any clarification? So these are the key concepts we are deploying. So for this setup, we are just looking at within an autonomous system. So this one could be the IPRAN network of a given region, just one region. So we are deploying BGP peering sessions between different nodes. We are using the loopback IP as the source address for the BGP peering sessions. So why we use the loopback IP, definitely you know the logical interface will never go down. If we use the physical connection between these two routers and this physical connection is down, then the BGP session will go down. But we are using the loopback IP as the source address for BGP peering sessions. CSGs will establish BGP session with ASGs, and then we have CSGs in a ring peering to two SGs for redundancy. So this CSG established two sessions, one with SG4, another one with SG3 for redundancy. Then SGs establish BGP session with CSGs and RSGs. So SGs will have peering to the RSGs, and we also have peering session to the CSGs. BGP groups are recommended. You can configure dynamic groups. So you can see that in this setup, you have this ring. So you will create a BGP peering group for every ring on the SG. Because remember, in a network, we can have multiple rings terminating on these CSGs, on these SGs. So it's always recommended that you have a group for every ring, and then you apply the repetitive commands on the group instead of applying them on every individual peer. Another thing that I need to mention is in this setup, SGs will be configured as the route reflectors for the CSGs. Remember, the CSGs have to learn the routes from the controllers and even the service route from the other CSGs. So we have the SGs configured as the route reflectors for the CSGs. RSGs can act as the RR for the SGs. And if you are connecting to the external network, definitely the RSGs will always be the route reflectors, unless you have separate route reflectors in the network. So for this setup, you know that also you have multiple SGs and you could be having multiple RSGs in the network. That's why it's always recommended to have the route reflectors, and then the SGs will only be peering to the RRs in the network. In the standard, many times we have the RSGs acting as the route reflector. So we don't have in the ASG BGP peerings. I've not mentioned that we have a BGP peering session between SG3 and SG4. No. We don't have a BGP peering session between SG1 and SG2. No. They are just peering to the route reflectors, which are the RSGs in the network. You don't have to establish meshed peering between the SGs. And then when you are controlling or controlling the route in the route exchange in the network, we always use route policies. So you have route policies configured to control route exchange in the network, and then it's also recommended that we implement BGP authentication. So this slide covers more details about the BGP designed for IPRAN network for intra-AS, just within an autonomous system, just within a region. This is where you will find such type of a setup, and you need to know where and who to configure the BGP sessions with. Any question?
Okay, sorry to draw you back a little. Yeah,
Yes.
sorry to draw you back a little. Yeah, for the ASGs, okay, you said it can act as a route reflector for the CSG. Am I correct?
It acts as the route reflector for the CSGs.
That's correct, right?
Yes.
Now, if you deploy another route reflector at the ASG point, okay, now the ASGs does not need to act as route reflector again, right?
Unless you are pairing BGP sessions between the CSG and the route reflector. Right. If you deploy a route reflector here, then it means we need to
Okay.
pair these CSGs with the route reflector.
Fantastic.
For
In
it to
this
be
case,
able
are you
to,
still
yeah.
pairing with the ASG? If you pair the CSG with the route reflector, are you still pairing the same CSGs also with the ASGs?
No need for that, because you know
Oh,
the route exchange will only between the CSG and the CSGs. I mean the CSGs and the route reflector. So you don't need to establish BGP sessions with the ASGs. If you have a route
so in
reflector,
this, okay, in that case, do you still need to deploy ASGs on the network if you have a route reflector replacing the function of the ASGs?
many times the ASGs will be the route reflector. I've never seen
Uh,
a setup where we have separate route reflectors in the access rings. I've never seen such a
uh,
setup. So you may
okay,
deploy them as
fantastic.
the route reflectors, but still they will be the ASGs.
Okay.
Yeah.
Okay, now for the RSGs,
Yes.
okay.
Yes.
For the RSGs, for the ASGs, the route the for the ASGs, okay, their route reflector can be the RSGs, right?
For which one? For
Or
the
for the ASGs,
yes,
if
yes.
we want to have a route reflector for the ASGs, we can ask the RSGs to be their route reflector, right?
Yes, yeah, the RSGs are always acting as the route reflector for the SG. Remember, they are the one connected to the external network and also to the controllers. So they will be getting the
Okay.
external route, they will be getting the route from the controllers, and then they have to propagate the routes to the ASGs. So it's true, yes, the
Oh,
RSGs will act as the route reflector for the ASGs.
okay. Now, sorry again. Now, do we have after this lecture? Do we have a configuration showing and establishing all these connections and showing the propagation of this route as a practical view or as a practical to demonstrate this? Do we are we going to have such a thing?
Yeah, the same way we have had a session on ISIS, we'll also have a session to discuss, to demonstrate BGP configuration. We'll have a lab for this similar setup that we are displaying to show you how
Okay,
you
fantastic.
configure and troubleshoot BGP on IPRAN network.
Okay, with respect to the route reflectors, right?
Yes, 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 yes. Of course, we will be configuring
Okay,
SGs at the route reflectors.
fantastic. Thank you so much.
Okay. So to the next slide. So when you have the intra-AS BGP, you need to, we have mentioned that we have mechanisms that are used to control loops, and these are built-in mechanisms. So we have the split horizon. This is a built-in mechanism. You don't have to configure the split horizon on BGP. It comes into play uh, itself. So you don't need to do any configuration. But you can see that if we are getting a route from R1 and this route is shared to R2, R2, yes, it has received an eBGP route. It will send this route to R3. When R3 gets the route, it will not propagate it to R5. So you find that we have a point of disconnect. This network will never know how to reach R1. It will never know, or it will never have routes to S100, because these routes will be dropped by R5. So we need to have a mechanism that can help us to ensure that we have connectivity end to end. And that's why we have mentioned that we have full mesh. You establish BGP peering sessions between all the routers in the network. We have the route reflection, which is recommended for the service provider networks, and we also have the BGP confederation that can also be deployed. But many times we always use route reflection. Easy to deploy, easy to manage, it's easy to configure. You only need to configure on the SGs or the route reflectors, no need to change anything on the client. So many times route reflection is used on IPRAN network to ensure that we have or to solve this problem of BGP split horizon. To the next slide, now we discuss a little bit about the INDAS BGP design. So when you have, this is the slide that we started with, you have your networks divided into different autonomous systems. You have to ensure that you have connectivity between these different autonomous systems. So you end up configuring the external BGP peering session between these different autonomous system numbers, and you have assigned an AS number, a different or a unique AS number to every region. You configure eBGP sessions between routers in different regions. And many times for these BGP sessions, we always use the point-to-point IPs. So depending on which option you are using, we have mentioned that you have option A, option B, option C. Many times we go with option C because it's scalable, but option A is easy to configure. So option C is slightly not easy to configure and even to understand. But many times we prefer option C that is more scalable for service provider networks. And for in the AS, I've mentioned that you also have external network. You could be having the IP core somewhere here. You need to ensure connectivity to the IP core. We always have the INDAS BGP or the external BGP deployed between these different networks. To the next slide, we are now discussing about because IPRAN network can never work alone. There is always the inter-AS connectivity between different autonomous systems. It could be within the IPRAN network, or it could be between IPRAN network and IP core, or any other kind of network that is connecting to IPRAN. So you need to understand these inter-AS BGP MPLS VPN options that are deployed to ensure that you have connectivity between different autonomous systems. So this is inter-AS BGP option A. You can see that for this kind of setup, we have MP IBGP sessions established between the PE and the SBR. You have IPv4, the normal VRF to VRF peering session established between the SBR. So the only challenge with option A is that one thing you require either to configure sub interfaces between different routers for different VRFs, or you can have physical interfaces configured between the SBRs. So how many physical interfaces will you need? It depends with the number of VPNs or the VRF that you have deployed in the network. And then in the other AS, you also have to configure the VPN before peering between the SBR and the PE. So whenever you introduce a new VPN in this network, the configuration workload is too huge. You need to configure this VPN on the PE. You need to configure this VPN on the SBR. You need to configure BGP peering session between the SBR for this new VPN. You also need to configure the SBR and the PE in the other autonomous system number. So you can see that this one, it's not a flexible solution. And another thing that I need to mention, that we never have MPLS running between the two SBRs. So you only have the normal unicast MP eBGP IPv4 peering session between these two routers for the different autonomous system numbers or the different VRFs that are deployed between the two autonomous system numbers. So this is only preferred for small network. Yes.
Okay, sorry, Martin, to draw you back a little.
Yeah.
In this concept now of options,
Yes.
option A, option B. Now, with this concept, where does the IP RAN fit in on this kind of deployment? Is it from the PE0 that you can have an IP RAN there, as in
Yes.
from this
Yes.
section,
Yes. Yes. Yes.
from the PE0, right? You can see from that PE0, maybe
Yes.
you have
Yes.
another PE2 for the IP RAN section. You can start your IP RAN section from this end down to the ASG to CSG before the BTS, right? All the traffic will back. This PE will be backhauling all the PE01 will be backhauling all the traffic, right?
That one primarily depends on the kind of setup that you have. Many times you see the RSGs. The RSGs will be acting as the SBR and the PE. But if you have
Okay, the RSGs will be acting as ASBR and the PE01, right?
yes, yes. So
For if
as
we want to put IP RAN here.
yes,
Okay.
remember, IPRAN, that is a special kind of setup. And when you have the Ps, remember the CSGs in the IPRAN network, they are kind of the Ps, right? Because they are connecting to the BTS. They are connecting to the BTS or the customer devices, the RAN devices in the network. So they are all acting as the Ps. So if you are to use the standard in the
That
ASBGP
is the
option.
CSGs.
Yes, yeah, the CSG, they are connecting to the customer devices, which in this setup we are
Okay.
calling the BTS, the RAN devices.
Okay. Okay.
But many times when we are establishing the in-the-AS communication, many times we do it on the RSGs because RSGs are always like the route reflectors in the network. So we only use them. This one will be acting as the SBR and also as the BPEs in such kind of a setup. But how you implement it purely depends on how your network is set up. You can still do the standard in the AS, BGP, and PLS options, but as I've mentioned, how you implement it purely depends on how your network is set up. If you have the route reflectors, well and good. You can just go ahead and implement option C directly without needing to configure the PE to PE peering sessions. But with option A, just to mention, this one we may not dive deeper into the nitty-gritties of option A because of time, but we have a separate, I think on the channel we have, on the Lyfey Technologies YouTube channel, we have a video demonstrating how to implement these options, option A, option B, and option C, even option C with route reflectors. So you need to go deep and understand these options before you can now transfer that knowledge and deploy it on the IPRAN network based on your setup. But the focus is on this point of connection between the two networks. We have S100, we have S200. At this point, we are just doing back-to-back VRF peering session between the two SBRs so that they can exchange the routes between the two autonomous system numbers. And then we have MPI BGP peering sessions between the SBR and the PEs. So this one could be the RSG, the PEs could be the ASG, because remember ASGs has a connection to the CSG. So once these routes, if we have MPI BGP peering session between the SBR and the ASG, these routes will be propagated to the SG. SG definitely with the standard IPRAN solution has already advertised a default route to the CSG. So we also have option B. So with option B, we have MPLS configured between these routers. We have MPLS configured here. And then we are doing BGP IPv4 label unicast between the SBRs. And now this one is Oh, I'm already on options. This is option B. Yes, yes. For option B, we have MPE BGP VPN v4 peering session between the SPR. So we don't need to configure VRF back-to-back VRF between the different between SBRs on the different VRFs. We are just doing MPE BGP VPN v4 peering so that they can exchange the VPN v4 routes between the different autonomous system numbers. And of course, we are configuring MPLS on this router. And between the SBR and the PEs, we are deploying MPI BGP VPN v4. So the routes are exchanged between these two routers, and then they are propagated to the PEs, and then the PEs is able to distribute the routes within the network. So one thing to mention that with option B, route targets are globally significant, and MPLS runs between the SBRs. But the only challenge is the SBRs will have to accept all the VPN v4 routing information, and then it has to maintain all the customer routes. So it has to keep all the routes that are coming in through the VPN v4 peering. So that one also requires a device with high capacity. Now to the option that is preferred for inter-AS communication, we have the option C. So option C, we have two solutions. We have one without route reflectors. We have another one with route reflectors. So if you don't have route reflectors in the network, you configure BGP VPN v4 peering between the PEs. But how many PEs do you have in your network? You have many PEs. So you can see that if you don't have the RRs, then you still have a lot of work to do for option C without RRs. So the most preferred solution is the one where we have RRs. When you have RRs in the network, we only establish MPE BGP VPN v4 peering between the RRs. And this one is more scalable. Imagine you have a new PE router coming in. You only need to configure the BGP peering session between the PE and the RRs. That is it. You don't need to configure any other node in the network. So you only touch on the connected RR, you configure the BGP session between the RRs, and that is it. You are able to ensure that you reach connectivity between the different autonomous system numbers. So with this, you don't configure VRFs on the SBRs, you only configure VRFs on the PE routers. So this is just a quick lookup on how to achieve connectivity between different autonomous systems within the IPRAN network. And next, we need to look at how to control loops between autonomous system numbers. So we have AS path. The AS path is primarily used to control loops between different autonomous system numbers. So you can see that if you have a route coming in from AS100, it's propagated to AS200. And if this route is propagated to AS100 again, this route will be dropped. It will be discarded because this route will be checking and found that it has its own AS within the route message. So it will drop the route. So this is how we control loops within the between in the ASs using the AS path attribute. If you get a route and this route has your own autonomous system number, you drop that path. You don't install it in your routing table. And now to controlling traffic flow. So on IPRAN network, you have mentioned that many times you have connections. If we go back to this kind of setup, you will find that, for example, in region 2, you have multiple connections. You have an exit to R16 in AS65-510. You also have an exit through AS65-513. So how do you control traffic to ensure that maybe primarily you want your traffic to go through this connection and not through this connection? So you can use different BGP attributes to ensure that you achieve this traffic control, and you will ensure that the traffic flow is optimal between different autonomous system numbers. So the first thing that we normally use is the AS path. So with the AS path, you can use it to control both inbound and outbound traffic. And how you do it is you can prepend the AS path. For example, you can see that in this setup, you have, if you go this way, you have two paths. You have this path and you have the other path. And maybe you want your traffic. So you have the lower path. I mean, this one is 1, this is 2. Where will traffic flow to? Which one will be preferred if you have two paths in this kind of setup? Anyone who can respond? Yes,
Yeah.
yes,
Okay, you can
proceed.
go.
You are raising your hand.
Yeah, yeah. Mr. Martin, before we go through using AS bus to control inbound, I want to add point. Okay, if we have many of root reflectors, okay, to prevent loop between all of these root reflectors, we can use cluster list or originator ID, right?
Which one? Just come again.
If we have several number of root reflectors, okay, so we can prevent loops between all of these root reflectors. We can use cluster list or originator list,
Yes,
cluster
yes,
ID.
yes, yes, yes,
Yeah,
yes. Yeah, we can have the cluster ID to control loops when we are having route
yeah,
reflectors deployed in the network. I agree.
yeah, yeah, to avoid loop between root reflectors.
Yes, yes,
Okay,
yes,
yeah,
yes, that's true.
I want to add this point. Yeah, okay,
Okay, okay, thank
thank
you.
you. Thank you.
So my question was, you have this kind of setup, you have R1 in S100, and then you have another AS500, you have AS400, you have AS200 and AS300. You have a destination network connected to these AS300. You have the upper path, you have the lower path. Which one will be used for forwarding traffic?
By default, this lower bus, it will uh, it will flow through AS 200 because this is one autonomous system. So if we want to control this, we can prevent. We can use fake autonomous system to add in this bus if we want to pass traffic through the upper link.
Thank you. That's true. So the lower path will be preferred because it will have the lower AS path length. So for us to be able to control traffic to flow, because why do we need to control the traffic? Maybe this one has a lower capacity. Maybe this one is 1G, this one is 100G, and you want traffic to flow using the upper path. So you need to use the AS path prepend to ensure that you can control the traffic flow and force the traffic to flow using the upper path. So that is correct. Thank you.
Okay.
Another thing is we can control the traffic flow also using the local preference. So for the local preference, we are controlling the outbound traffic. You can see that in this kind of a setup, you have multiple exits. Sorry. You have exit through ISP1. You also have exit through ISP2. And if you want traffic to flow through one of the ASS, then you can use local preference. So local preference, it will help us to determine the optimal route when traffic is leaving an AS. So by default, this value on Huawei will be 100, 100, 100. So any router that is running BGP will have a default local preference of 100. So what you can do is you can adjust these values. Maybe you want to load balance traffic. You can see that in this setup you have two networks. You can use local preference to ensure that traffic to this network goes through this side and traffic to 10.11 goes through the other side. So the higher the local preference, if a route has a higher local preference, it will be preferred. So you can use the local preference to control the outbound traffic from an autonomous system to the external AS. And I've mentioned that the default value is always 100. You can also use MED. MED, this is like cost. So the smallest MED value is always selected as the optimal route. So you can see that in this similar setup, you've set MED 100 for this network, you've set 200 for this network, so our traffic will flow this side because we have a lower MED. MED is similar to cost in IGP, and the default value for MED is 0. Next is using the preferred value. So preferred value, I've mentioned that this is similar to weight on Cisco, and this is preferred value is Huawei specific and valid only on the device where it's configured. So this one can also be used to control the traffic flow between different autonomous system numbers. You can see that if you have multiple routes available to the same destination, the route with the largest preferred value is selected as the optimal. So what you can do is you have your advertising routes to this AS from these two autonomous system numbers, and you want your traffic to flow via ISP1. So you will configure a higher preferred value for this path, and you configure a lower preferred value for this ISP2. So you will have your traffic following this path because you've configured a higher preferred value. And also by default, the route slant from BGP is set to 0. So the default preferred value is set to 0. Any question so far? So some best practices when you are doing deployment for the IPRAN network, we always use private AS numbers. Remember, this one also improves the network security, and because the private AS number definitely it cannot be propagated through the internet. So we always, and we don't have many public AS numbers, so we always go with the private AS numbers. And you assign a region, you assign it a different autonomous system number. You deploy BGP groups that will help you to manage the configurations well, and also it reduces the number of commands that you run on the device. If you have 100 devices, if you are configuring every individual device, then you don't configure the groups, it means you will have 100 repetitive commands on the device. Even when you are troubleshooting, you have to go through all these commands, which makes it complicated. So we always deploy BGP groups. It's recommended that you configure BGP authentication, and when you do BGP authentication, it's always recommended that you configure same parameters, same BGP parameters between two different devices. If you don't, the BGP pairing session may fail to come up. So configure authentication, either MD5 or even the other secure like the SSL or any other available authentication mechanisms that will help improve your network security. You also need to configure BGP fast convergence mechanisms. You can configure BFD and also adjust timers. You need to deploy in the AS BGP MPLS VPN option C. It's more scalable. And then when you are doing route import between different autonomous system numbers, you always have to use route policies to control route exchange within and outside the AS. So don't import everything. Ensure that you use route policies to control what is exchanged between the different autonomous system numbers. And now we are to the question and answer session. The floor is open for questions, clarifications, and even additions.
Okay, sorry. Can you go back to the diagram where you did that option A first? Let me see where you numbered as we are going to configure the ROSGs for the ROSGs for this option A, the nodes that can function as the ROSGs. Can you label them again between the PE and ASBR?
We have, I've mentioned that many times the P's are the CSGs, right? But the P routers, you can consider them. Of course, the P routers, we cannot say that they are the ASGs, but in this setup, the SBRs are the ones that are acting as the RSGs. So you will find that in the implementation that I've seen, you have the SBR as the RSG and also as the route reflector. So this one will be the RSG. It will also be the RR.
Okay.
But you can have separate RRs in the network. You can have a
Okay.
device that is primarily acting as the route reflector. And this is why
Okay. So
we discussed option C, where now you have device acting as the RRs in the network, and then the RSG will just be like the SBR, just giving us connection to the external networks, and that is it. But for the route exchange, we have pure RRs in the network.
okay. So the PE01, you said it will act as the ASG, as the ASG, right?
Yes.
Okay. 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 Thank you.
The CEs of definitely could be just like the BTS, but when we extend, we can have the CSGs coming in and connecting to the
Oh,
ASGs and then connecting to the BTS in different
yes.
locations.
Okay.
Yeah.
Thank you.
Questions as we finish.
Martin, sorry to ask this. Maybe you'll just update me here. For the private SN numbers,
Yes, yes.
uh, do I come up? Do I come up? Do I design them myself, or I have to consult Iana?
No, for the private, you just design yourself. Because remember, those
Mm-hmm.
ones they are not going to be propagated to the internet.
Mm-hmm.
So you just choose which one you want to use. A service provider will definitely have the requirement or the setup standard, like this is the range of the S number that we are using. So you just go ahead and pick on the available private S numbers, and then you can use any.
Okay, thank you very much.
Okay, welcome.
Hello, Martin. Thank you for your wonderful explanations.
Thank you.
One question I have, very general one, please.
Yes.
So if we, just for the benefit of me and others also, now there is a lot of routing knowledge here.
Yes.
Just to see the bigger picture, if we have, let's say, an SDN controller,
Yes.
yeah? Now those SDN controllers would be interacting with the BGP claim using some APIs, right?
Yes.
So is that sometimes it's hard to find that kind of knowledge because different people use different this is like a different parts, for example, MME, as you were saying in other part, MME needs to interact with the routing logic also sometimes to switch the gateways and etc. S gateways, P gateways.
Yes.
Is there? Do you have any comments on how these interaction works actually? And also, final part is there is a CSG. You keep saying that either the cell site router or cell site gateway that has got some fiber termination, right? Optical.
Yes. Yes.
So now IP plus optical is controlled by SDN controller also. That's called sometimes transport SDN controller.
Yes.
Is there any comment on this, or is it outside this particular training sessions?
I think things to do with SDN, they are outside this session, because you see now that is
Mhm.
of course the networks are evolving. We have the new technologies coming in. We have the SDN controllers being deployed. we have the automation, we have so many things coming in. So
Yes, yes, yes.
I don't know which specific area you want me to comment. Maybe you can narrow down to.
Good, very good. Thank you. I like you. I like you deflected back to me in a good way. Yeah. So I'm actually looking at not latest all AI network automation, Open RAN. You got all. You can throw in everything that you want. But I
Yes,
think in reality, let's say LTE network. Yeah, legacy LTE network compared to 5G standalone and other stuff.
yes,
If we take a legacy 4G data network, if the data path is coming and if there's a IP optical infrastructure layer in it,
yes.
yeah, that is probably best I can narrow it down to.
Yeah, because if you have the SDN controller, definitely, I know we normally configure the BGP to pair with the, I mean the, how do I call it?
Both MME and do you have kind of connections between logical connections between MME as well as S/P gateway to this BGP controller or through some APIs or?
You see, if what I understand is these controllers are primarily, you mentioned the transport layer. So they are just controlling the transport layer, and they will get these routes from, if you have, I need to draw. Let me clear this. So if this is the kind of setup that we have,
Mhm.
we'll have a kind of a controller somewhere, right? And this
Yeah.
controller is primarily in charge of controlling the traffic flow in the network.
Mhm.
And then let me get another shape. Now we are configuring BGP so that this controller and the device and the edge device, they are able to exchange the route, right, through BGP. It's a special
Mhm.
kind of BGP. How do we call it? I forgot the name.
Mhm.
So once this device, probably the RSG or this special device that we have mandated with the responsibility of exchanging the route, it just has to forward these routes, whether these routes are coming from the S gateway or the B gateway, because if these are the connodes, the RSGs, then they are connected to some controllers.
Yeah.
So they are getting these routes and they are sending these routes to the controller. And then the controller will do the path computations and deliver the best routes or the selected routes back to the devices, right?
So that hexagon is a BGP controller you're talking, that
No,
hexagonal
the
thing
one
on the
you
top.
call the SDN controller, kind of.
Ah, right. Okay. Okay.
So
Something
because
like an open daylight or something like that. Yeah. Okay.
yes, yes, because it will be primarily in charge of the path computations, right?
Mm-hmm.
And
Yes.
then it
Yes.
has to
Yes. Yes.
deliver these the calculated routes or the calculated roads will now be delivered to the devices. So these routes,
Mm-hmm.
the S gateway, the P gateway route, they are all coming in through this device, and then this device now is in charge of sending, collecting all this information that is
What
required by the controller. Yes.
What is the device, Martin? The bit in between your two circles and an IP address there.
This one I'm calling them the
What
RSGs.
is that device?
RSGs, the
Is
RSGs,
that
the one
your
that
PGP router? RS, your gateway. Okay.
yes, yes. It could be the
Okay. Understood. Yeah.
RSGs, it could be it depends with the location of the controller. It could be the IP core device, it could be the IPRAN device, but this device will be in charge of collecting all the routing information and taking this information, forwarding it to the controller, and then the controller will do the path computation and then deliver the path computation back to the devices. Is it the PSEP or what is it? Is it PCEP?
Uh, oh, I see. PSEP. Okay.
So yeah, I think
Yeah.
that discussion, yeah, could be out of the scope,
Yeah. I
but
know. Thank you, Martin. Really
we
appreciated. You went beyond that. My for others, for others also listening in, thank you for that. One point is that my interest is how can the mobility events can be, how can the mobility events can be learned from the network to the IP routing or the or the SDN controller that's working with IP routing. That is a looks like $1 million question, which some of it you addressed. Thank you so much for that.
Yeah, but that one, I think it goes back to the signaling because I'm sure there is always signaling between the device that is moving and the controllers, which could be the MME and the S gateway or any other controller. So this device and the moving device should be relaying some kind of information between them. And once they relay this information now, yeah, there should be some magic happening in the background, and then we are able to.
Yeah, thank you, Martin. Thank you so much again. Much appreciated.
Thank you. You're welcome. Any other question from the team as we close our session?
Thank you, Martin. Thank you for this informative session.
You're welcome.
Thank you.
You're welcome.
Bro, you will hold any session for IP core or not?
We need to first complete the IPRAN session and then we can
Okay.
discuss about the IP core. But yeah, the focus that we're trying to do is to first complete the IPRAN session. We still have a couple of sessions pending. We need to do a lab on BGP. We need to discuss about the service deployment. We need to discuss about the QoS and many other operations that comes in when you have the IPRAN network. So once we finish that, we can consider having an IP core session.
Yeah.
Yeah.
Great. Thank you, Martin.
You're welcome. Any question about the BGP? Any question about what we've discussed from any of the members? Let me check on the chat. On which router is eBGP implemented? Many times we implement eBGP on the RSG. Remember, this is the device that is connecting us to the external network. So many times we implement it on the RSG, but sometimes we have other external connection on the ASG on some special occasions, so we can also do it on the ASG, but primarily it's normally implemented on the RSG that sits on the edge of the network. Any other question that includes?
Hi, Martin.
Yes, Emmanuel.
Hi, how are you? So yeah, just trying to get a question, but outside the IPRAN architecture.
Yes.
Basically for IPT.
Yes.
Besides Looking Glass, yeah, which other tool would you recommend for for that to just root analysis and just a little bit of catching an overview of the entire BGP routing table?
Anyone who can respond to that? I'm also learning. I'm also in class. Emmanuel, you can repeat your question for the members to get it clearly.
Oh, okay. Yeah, so I was saying just a little bit outside the IPRAN architecture, yeah?
Yes.
I'm looking at the IPT architecture.
Yes.
And so usually you would want to study the BGP routing table in a global manner. So one of the tools you use is Looking Glass. So just wondering, is there another tool out there that probably somebody knows that could also be of use? Yeah.
Anyone who can respond to that? Anyone who has a different tool?
Yes.
Yes.
I know of Hurricane Electric.
Jonas, could you do the honors of just typing the tool in the chat box? That would be great.
Jonas, you can type the name of the tool in the chat. Wait, type on the chat.
Thank you, Jonas.
Internet Services BGP Toolkit. Because I've only used the Looking Glass, I haven't used any other. That's why I'm allowing members to share their, if they have used different tools in their work environment. Any other tool or any other question as we wind up our session?
Martin,
Yes, yes.
could you add short brief about segment routing in incoming session for IPRAN, or you can't do this
Yeah,
for SR? Hmm.
we can talk about segment routing. I know that
Hmm.
is a hot
And
topic, and
how to use in IPRAN?
yes, of course, we have segment
Hmm.
routing deployed on the IPRAN networks already. So yeah, that's
Hmm.
something that we can discuss about. No problem.
It will be okay.
Yeah,
Thank you.
because
Thank you.
it's a new
Hmm.
technology that is being deployed on both IPRAN and even IP core. So yeah, we need to have an understanding of segment routing.
Hmm.
Yes.
Okay.
Any other question?
Okay, Martin, my last question is, I know you have different engineers here who have worked with different vendors.
Yes.
On my end, I've worked with MikroTik for deploying BGP. At times I do face challenges. I don't know if I'm the only one facing challenges in terms of performance. When I route like 8G, at times that router freezes. I don't know if I'm the only one experiencing this, or maybe you can recommend me the best vendor that you know. I think I'm good at Juniper and Cisco, but I've never tried them on the network.
Okay, of course. I think MikroTik also has high-end router, so it depends on first which kind of MikroTik device that is not able to handle 8G traffic, because you see 8GB that is still very little traffic, right? So it depends first with which type of MikroTik device you are using. But again, all these other vendors, be it Huawei, Nokia, Cisco, Juniper, they also have very good devices that you can consider to deploy in the network, depending on your requirements.
Yeah, also wanted to say that you can check the CPU utilization when you load such traffic. So it could be that your MikroTik is compromised in terms of the CPU. So you need to upgrade.
Yes. So you need to know the specifications of that router, know the performance, I mean, in terms of the capacity that it can handle. It could be that it's limited by just the specification. That's the maximum that it can go. But I'm sure there are other MikroTik devices that maybe have better performance that you can also consider, or you can consider other vendors like Nokia, Huawei, Cisco, Juniper. So it purely depends on the requirements of your network.
Okay, thank you very much.
Any other question? The last question, Jackson.
No question. Sorry. Yes, I muted. Sorry.
Okay, no problem.
Okay, maybe. Thank you very much.
You're welcome. Any other last question before we close the session? Any comments? And I just need to mention that, yeah, the recording will be uploaded on our YouTube channel. If you are yet to subscribe to our channel, kindly subscribe to our channel. And there are other recorded videos on lab simulations on Huawei. We have lab simulations on Nokia, Juniper, and many other content that is being shared on our channel. So take some time, uh, support us by subscribing to our channel, and also you can share with your connections. And also for this type of training, you can also reach out to your connections, let them know that we have this type of training. They are allowed to join, it's free. And yeah, we share the knowledge, we exchange knowledge, and yeah, we continue learning every day. So I hope you've enjoyed this session, and I hope to see you all in our next training session. That will be episode 5, and we'll be covering how to configure and troubleshoot BGP on IPRAN network. Thank you so much for joining, and see you in our next session.
Thank you, Martin.
Thank you, Martin.
Bye.
Bye.
Thank you.
Thanks, Martin. Bye bye.